vectors, keep two things very clearly in your mind. The number one thing is a vector is head minus tail coordinates. That is number one, with appropriate I cap, j cap, k cap, etc. So vector is head minus tail coordinates, number one. Second is when you move a vector parallel to itself, it doesn't change. Like if this is a vector, if this is a vector and this is the head, that is over here, there is an arrow, black cap is an arrow, and this is the length represent the magnitude. As far as I am moving these vectors like this, that is parallel to itself, this vector will remain same. If this is, we are saying this is 5 I cap, so whether it is like this or like this, I move it like this or I move it like this or I move it like this, it all the time remains as 5 I cap only. But if I slightly change the rotation, that is I change the angle, that is the direction has been changed, or I elongate it or shorten it, then the magnitude is changed, so it means the vector is going to change. So whenever we move a vector parallel to itself, it doesn't change. And vector is also head minus tail coordinates. When we say vector is head minus tail coordinates, what does it mean? It means if this is, we say x-axis, this is y-axis. Now let's say a person has gone from here to here, right? So this displacement is going to be 1 and 2 I cap units. What's the unit? If this is 1 meter, we'll say meter only. If this is centimeter, if this block is 1 centimeter by 1 centimeter, we'll say it is 1 centimeter. Similarly, if this body has gone from here to here, once again by 2 blocks, this displacement is also going to be 2 I cap meter or centimeter. If we look at its coordinates, that is over here, this is x-axis. So this is coordinates of this as far as x and y is concerned, z is equal to 0. So 1, 2, 3. So this is 3. So x coordinate is 3 and y coordinate is 1, 2, 3, 4, 5. So this is 3, 5 and this is 1, 5. So this is this minus this, 3 minus 3, from x will deduct x only. So 3 minus 1, that is 2i. And from y minus y, that is 5 minus 5, it is going to be 0. So we'll say this is 2 I cap displacement in meters. Similarly over here, so this is head minus tail coordinates. What are the head coordinates? It is 0, 1, 2, 3, 0, 3, and this is 1, 2, that is minus 2 and 3 coordinates. So x coordinate head minus tail, 0 minus minus 2, 0 minus minus 2 I cap. So that's, this is equal to 2 I cap only, and over here that is y is same coordinate, we are not getting into it. So this is also 2 I cap meter only, and this is also 2 I cap meter only. So this is head minus tail coordinates, we get a vector. So take note of this, that is vector is head minus tail coordinates with appropriate I cap, j cap and k cap. We shall be doing these things in details also. And also when you move a vector parallel to itself, it doesn't change. If we have two vectors in space and we wish to add these vectors, that is we say that is we want to find a resultant of these two vectors, or we wish to add these two vectors. To add these vectors, what we do is we join them from head to tail. Let's say our vector is over here and we say this is like this. To represent as a vector, one is I can darken it. This can be darkened as it is darkened in books, but over here it may not be possible for me all the time to blacken it. So what I do is I write it like this and I put an arrow like this. So it means this is a vector quantity. If I write like this and put a mod sign, it means this is the magnitude of vector. So it means now I shall be just be talking about the 5 Newton, 6 meter. I will not be talking about the direction. So this is purely the magnitude. But when I say over here that is this represent vector, so over here I'll write as 5 I cap, 10 j cap, etc. So this is the magnitude only. This is magnitude, and over here we have a magnitude also and direction also. Let's say over here this is a vector A is lying like this, and in space or in xy plane, let's talk about the xy plane only, and over here we have a B vector. We are interested in finding what is A plus B. if we have to find a plus b, so this rule, that is how to add the vectors, it says join the vectors from head to tail. It says if you have one vector, move a second vector parallel to itself, that is parallel to itself, and join the head of the first to the tail of the second. So when we move this vector from here to here parallelly without changing its orientation or without changing its magnitude, so when we move a vector parallel to itself, doesn't change. So b comes over here. Then the resultant is from the tail of first to the head of second. When we join it like this, so this vector will be called a resultant vector, and this will be said as a plus b. That is, this is a resultant vector of both these vectors, that is a plus b is in this manner. First you take one vector, move a vector parallel to itself, and its tail should join the head of the first vector. Then the vector originating from the tail of first vector and culminating at the head of the second vector is going to represent the resultant vector, and it is represented as r is equal to a plus b, that is resultant of a plus b. So now what does it mean? It means if we have a x-axis over here and y-axis over here and origin is here. Let's say a person goes 5 meter this way and 3 meter this way. Someone says, what is displacement? Displacement is obviously going to be like this. It is going to be like this. This is the displacement. So I'll call this as resultant vector r. So this resultant vector is what? This is, we see that is over here this triangle. This seems a triangle, and there is a head to tail combination also. So this vector can be written as 5i cap, and this can be written as 3 purely, this is purely on the y-axis, can be written as 3j cap. So we'll say that is resultant is equal to 5i cap plus 3j cap is the resultant vector of this and this. Now don't try to simplify it further. Don't seek that is there should be some value 2, 3, 4, etc. No, this is good enough. Resultant is 5i cap plus 3j cap. It carries both the things into it. It carries the meaning of magnitude also. It carries the meaning of direction also. If we say resultant is 5i cap plus 3j cap, so it means the magnitude, that is the length of this displacement, that is the magnitude of this displacement is certainly, that is the magnitude is going to be equal to this square plus this square under root, Pythagoras theorem, 5 square plus 3 square, because this is 90-degree angle. So this is the magnitude. And can we take that, deduce the direction from here? That yes, we can deduce the direction also. That is tan theta perpendicular base. This length is 3, this length is 5. So tan theta is equal to 3 by 5 also. So this is 25 plus 9. So this is root 34 meter. So it means if a person goes directly in this direction at an angle theta is equal to tan inverse 3 by 5, and he goes root 34 meter, he will exactly find himself at the same spot as if he had gone 5 meter along the positive x-axis and then 3 meter along the positive y-axis. So we'll say this vector is resultant of this and this vector. Now let us say we have vector over here, let's say from here to here. This is a vector. This is tail of vector and this is head of vector. And let's understand it just with the displacement vector first, without getting into the force vector or velocity vector. Let's understand simply in terms of displacement vector first. So a person has gone from here to here. He could have got the same result if he had first gone from here to here and then from here to here. So this resultant vector is of what? Purely something about I plus purely something about j. It means if we have any vector which is inclined at some angle or so, we see how it can be produced by a simple displacement along the x-axis plus along y-axis, or if it is required along the z-axis also. So if a person has gone from here to here, we can simply break this motion. One is purely along x-axis, the other is purely along y-axis. Purely along x-axis, we say it is 2i cap because this way it is positive I cap. This way it is minus I cap, this way is plus j cap, this way is minus j cap, and then from here to here is 1j cap. using the triangle law of vector addition which we had just done, that was triangle law of vector addition. So this resultant vector can be represented as 2i cap plus 1j cap. So simple. And when we say we have to add the vectors, this is one vector, let's say vector A, and over here is a vector B. We move this vector first parallel to itself and join its tail to the head of this first vector, so that when we move a vector parallel to itself, it doesn't change. So this is B vector, the vector which originates from A vector, from the tail of first vector to the head of second vector. This is called resultant vector, and this way of adding it, that is R is equal to A plus B, we have a triangle. This is a triangle only, and this is called triangle law of vector addition. Triangle law of vector addition. So this is triangle law of vector addition. And similarly over here, when this is resultant, it can be broken into two parts. One is purely along the x-axis, the other is purely along y-axis. If we have a displacement vector like this, how can we represent it? How can we break it purely along the x-axis and purely along the y-axis? If you have to go from here to here and you are constrained to move purely along the x and y-axis, so what will do? You will first go from here to here, and then you will go from here to here to find yourself at the same position if you had gone in this direction. So this is what? This is going to be minus 2i cap, and this is what? In the positive z-axis, so it is going to 2j cap. So in this case, resultant will be written as minus 2i cap plus 2j cap. This is how you are going to write it. So from here, you can take out both the things. You can take out the magnitude also, you can take out the direction also. Magnitude is going to be this square plus this square under root, that is in this right angle triangle. This length, that is magnitude, is what is the length of this displacement, what is the length of this vector. So length of this vector, this is magnitude. So this is going to be, this length is going to be this square plus this square. This is 2 units, this is 2 units. So this is 2 square plus 2 square. This is the magnitude. And the direction is theta, that is tan theta is equal to 2 by 2, that is 1. So theta is equal to 45 degrees. So it means if you go, this is root 8 meter, means if you go root 8 meter at angle of 45 degree, you will find yourself exactly at the same position. If you had gone first 2 meter this way and 2 meter up, the displacement would have been same in both the cases. We can also add more than 2 vectors also using the same principle what we have followed in triangle law of vector addition. Like if we have vector A over here, vector B over here, and let's say vector C over here. What we do is we move this vector parallel to itself, join its tail to the head of this. So this is B, this goes off. We move this vector parallel to itself to join its tail to its head. It comes over here. Then the polygon law of vector addition, polygon law. Polygon law of vector addition, it says the resultant vector is connect from here, that is the tail of the first vector to the head of the last vector. So this is going to resultant, and this resultant vector is going to be A plus B plus C. This is nothing but purely an extension or application of triangle law of vector addition only. If you see, that is first if we say A plus B, if we add A plus B using triangle law of vector addition, so this is going to be A plus B only. A vector plus B vector, triangle. So this is going to be A plus B only. And now once again we can use triangle of vector addition. So this is going to be what? A plus B plus C. Once again we are using the same principle. So polygon law of vector addition is nothing but it is only a kind of extension only of triangle law of vector addition. In triangle law of vector addition or polygon law of vector addition, how we join the vectors, that is tail of one to the head of the other. We also have a parallelogram method of vector addition where we join the vectors tail to tail, and these are two vectors whose resultant we intend to find out. Like parallelogram vector addition, it says, parallelogram method of vector addition, it says, if you have two vectors, this is vector A, and over here you have a vector B, you move this vector and join these two vectors tail to tail. That is the first step. We are talking about the parallelogram law of vector addition. So this is vector A, this was vector B. We move this vector and join these two vectors tail to tail. Once we join it, then what we do is we construct a parallelogram parallel to this, and the second line we draw parallel to this vector. So this is a parallelogram. The parallelogram method of vector addition says that now the vector which originates from the tail of these two vectors where they are connected to this diagonal, this is the resultant vector. Obviously, if you see, if this is vector B, this and this they are parallel, and in parallelogram the opposite sides they are equal also. So if this is B, then certainly this is also B, and once again A plus B is going to be equal to resultant only. So once again this is nothing but extension of triangle law of vector addition only. And in this case, if the angle between the two vectors is theta, then our resultant magnitude is going to be magnitude of A square plus magnitude of B its whole square plus 2AB cos theta is going to be the length of this diagonal or magnitude of this resultant. And if you have to find what is the angle this resultant is making with this vector, so what we can do is we can construct over here our right angle triangle. So if this is theta, this and this they are parallel, so this is also theta. If this is B, so this is also B. So if this is B, length is B, so this is going to be B cos theta in this right angle triangle, and this is going to be B sin theta. Right? Now we see this bigger triangle. In this bigger triangle, tan alpha, in this bigger triangle, let's say we call it as X, Y and Z. Now we are talking about X, Y and Z. So tan alpha is equal to perpendicular base. What is perpendicular? Perpendicular is B sin theta. When we say B, it is purely the magnitude only. It is not the direction. We can also write magnitude like this, or we simply write it as B. It means the magnitude of vector. So it is B sin theta perpendicular by base. Base is what? A plus B sin theta. So it is A plus B sin theta. We have both the things. We have magnitude also, we have direction also. So this is parallelogram method of vector addition, which is nothing but once again an extension of triangle law of vector addition only.